our invited talk by two distinguished speakers in the field of inorganic and supramolecular chemistry. It's my honor to introduce our first invited speaker for this session, Dr. Orijit Das, sir, the Associate Professor and Head of the Department of Chemistry at Bir Bikram Memorial College, Agartala, India. Dr. Das he has successfully completed two prestigious research projects funded by SARB, Government of India. He has guided 6 postgraduate interns, a project fellow, and a postdoctoral fellow under these projects. Dr. Das is known for his exceptional contributions to science pedagogy. He has developed 22 time-efficient, innovative teaching methods since 2013, Indian Science Congress, India Academy of Forensic Sciences, and the Indian Chemical Society. He is also a recognized author, educator, OER, New Zealand. So today, Sir will deliver a talk on LP and NC discriminate hybridization with aromaticity reactivity patterns.
So I always place myself as a gardener for my flower-like students, and this will be my identity. Thanks. First of all, I want to give my cordial thanks to the Department of Chemistry, ICFAI University, mainly Dr. Shubhadeep Roy, Amitabh Sharma, Tufan sir, and HOD in Organic Chemistry, along with Innovation in Chemical Applications. And today I shall discuss the topics LP and NC, discriminate hybridization with aromaticity. Here LP stands for lone pair and NC stands for negative charge. So today we see how classification of lone pair and classification of negative charge discriminate or differentiate hybridization with aromaticity. Outside the book, that is, while you read the book, you must read the innovations which makes the subject metabolic, time economic, and intriguing for students and educators both. And the simple thinking makes chemistry metabolic, intriguing, and time economic be the objective of innovational journey. What is mnemonics? In mnemonics, the first letter M is silent. So mnemonics is a learning device through which we can remember anything in our brain long time. And there is a internal relations between mnemonics with sustainability. How? In chemical education, sustainability means any object that lasts over time in human memory. So we can say mnemonics and sustainability both are correlated with the long-term journey. Topic 6 for mainly for UG and PG level students. So hydration, we know hydration is nothing but a mixing of two components. In case of chemistry, the chemistry is nothing but the orbitals. So hydration is nothing but the mixing of orbitals in different ratio to get some newly hydrated orbital, that is mixed orbital. E means valence electron, Ma means monovalent atom, C cationic charge, and A for anionic charge. But it will be observed that when we predict hybridization state, there is a huge limitations of these conventional formula. Power of the hybridization state. When SP, so here you see the conception regarding power of the hybridization state will be changed. Here I treat the power of P as the power of the hybridization state. So in case of SP hybridization state, the power will be 1 and in case of sp2 power will be 2 of sigma plus lone pair minus 1. That is, you first count the total number of sigma bond and lone pair, sigma and lone pair, to get the hybridization state. So this is the first example for which we see the limitations between conventional, as per conventional formula, then it will be observed that the value will be 3. It is wrong. Actually, for cyclic ozone, the power of the hybridization state and the hybridization state will be sp3 instead of sp2. So this is the, so T as Lp, that is total sigma plus lone pair will be 4, and the power of the hybridization state will be 4 minus 1, 3, and the hybridization state will be sp3. So this is one of the drawbacks of conventional method solved by innovative ones. Second one, SH, use innovative formula, it will be sp3 and it is correct. So this is another drawbacks. So there is a huge number of drawbacks of conventional formula, and all these, you should find all these in this paper. This paper published from Indonesia in the Journal of Education and Learning in 2020. Predicting the hybridization state at negative charge. S stands for sigma. So you first find out total number of sigma bond and any localized negative charge is there is not present or not. Then you sum up the total sigma with LNC and we subtract 1 from this. And this formula should be used when you predict hybridization state of any heter atom in heterocyclic compounds. Here, LLC should be replaced by LLP. LLP stands for localized lone pair. When, so lone pair can be classified into two types, localized lone pair and delocalized lone pair. You see the figure. When lone pair containing atom, lone pair means number of electrons in the outermost orbit should not take part in bond formation. This is lone pair. Okay? So lone pair containing atom means heteroatom. So when lone pair containing atom and when lone pair containing atom directly attached with single bond at one side and double bond with other side, then this lone pair treated as localized lone pair. In this way, student can easily classify which lone pair treated as localized and which one is planar, that is all carbon atoms having sp2 hybridization state, third one conjugated, and fourth one 4n plus 2. Here, in the fourth one, here I replace this 4n plus 2 with a value. In the innovative way, you predict a value. If a value becomes even number, then it will be aromatic. If a value becomes odd number, then it will be anti-aromatic. So what is a value? You see, A is A equal to pi bond plus DLP plus 1. 1 is a constant terms. So total number of pi bond present in the cyclic system with delocalized lone pair with 1. If this A value become even number, then it will be aromatic. If this A value become odd number, then it will be anti-aromatic. And we know aromatic compound is more stable than anti-aromatic. So, classification of lone pair discriminate hybridization with aromaticity. Here you see, LLP used in hybridization by using this formula, right? And DLP used to predict aromaticity by calculating a value. So in this way, by classification of lone pair, we can easily discriminate hybridization with aromaticity. So the hybridization state of sulfur, because without prediction of hybridization state, you can't say it is planar. Because planarity means all atoms, it may be hetero or carbon, must have sp2 hybridization state. So for the in case of thiazole, you see, you predict the hybridization state of sulfur. So sulfur having two lone pair, one is in LLP mode and another is in DLP mode, right? And sulfur directly attached with two single bond. So there is 2 sigma, right? So total number of sigma. So here 1 LLP and 2 sigma bond. Because in double bond there is 1 sigma 1 pi and in single bond there is a sigma. So there is a 2 sigma and 1 LLP. So 3 TSLP value. TSLP value will be 3 for the prediction of A value. How? In case of thiophene and quinoline, you see here. In case of thiophene, one lone pair is in DLP mode and another is in LLP mode. So there is only 2 pi bond plus DLP plus 1. So there is 2 pi bond plus 1 DLP plus 1. So the value will be 4 and it is even number and hence it will be aromatic will be 4. So 4 plus, since DLP 0, so we put here 0 plus 1. 1 is a constant term. So the total value will be 5. 5 be odd number. So if A value becomes odd number, then it will be anti-aromatic. So in this way, azosine is anti-aromatic. Next, negative charge. Classification of negative charge discriminate hybridization with aromaticity. In the same way, LNC, that is localized negative charge, used cyclopentadienyl anion, cycloheptatrienol anion, phenyl carbanion, huge number of example is there. So here cycloheptatrienol anion, in this example you see these carbon bearing negative charge, we should predict hybridization state for this carbon bearing negative charge. These carbon bearing negative charge, these negative charge treated as LNC or DNC, localized or delocalized, because it is directly attached to single bond from all sides. So it is delocalized or total number of sigma plus sigma plus LNC will be only only 3, because there is a 1 hydrogen atom is there. Here there is a 1 hydrogen. So 3 single bond, 3 sigma. There is no, and the hybridization state will be sp2. Right? So in this way you can predict the hybridization state of non-heterocyclic organic compounds. Now, use of DNC for the prediction of A value for non-heterocyclic organic compounds. How? Here you see, in case of cyclopentadienyl cation, we know cyclopentadiene is much more acidic over cycloheptatriene. Towards forward directions, which produces maximum number of proton and which increases the acidic character of cyclopentadiene over cycloheptatriene. So, in case of cyclopentadienyl cation, anion, here you see there is 1 DNC, so pi bond will be 2, 2 plus 1 plus 1, 4, even number, so it will be aromatic. So very simple.
The negative charge is delocalized, right? Cyclopentadiene anion.
Yeah. These negative charge.
Then you are writing localized negative charge 1. How it is found?
Delocalized?
No, localized negative charge.
So these are the references. These are external links. Okay. And this is very important. Just you see. is nothing but the number of carbon atom. Y with the number of Y is nothing but the number bonds are present there. In this formula, in formula 20 sigma bonds, in case of cyclic system, this formula should be used. So there is huge number of formula, and this formula 20 is used for cycloalkyne or cycloalkyne systems. Okay, this one. Now, these two educational tools, these are freely access, launched in USA. First one launched in 2015 and second one launched in 2018. The number of carbon and hydrogen in the box. Suppose I put here C 300, so this will be the result. It is invalid for open chain alkane. In case it exists as polycyclic alkane, in this case sigma bond will be 650. It exists as open chain sigma pi single double bond, all data are given there along with degree of unsaturations.
Any questions for the presentation? So now the platform is open for question answer. If anyone wants to ask question to sir, the platform is open. Directly consult with sir. Anyone?
Because when you predict the hybridization state sp3, then it will be homoerotic.
For sp3?
It will be homoerotic. Mono already predict the power of the hybridization state. So when the power of the hybridization state will be sp3 along with sp2, then it will be homoerotic.
And for non-aromatic?
For non-aromaticity, either it is acyclic or it is non-conjugated. So if it violates first any one of first three, then it will be non-aromatic. Thank you.
Any more questions? MSc and PhD in chemistry from the University of Kalani, West Bengal. He antipolar chemistry, coordination chemistry, and the development of metal-based anti-cancer drugs. Dr. Adhikari is currently supervising 4 PhD students. He has authored numerous journals. In addition, he has edited 2 books and contributed 8 book chapters. Dr. Adhikari holds 2 Indian complexes. Beyond his research, he served as a guest editor for Frontiers in Chemistry and is a member of editorial board of the International Journals, engineered via cooperativity effect between terrestrial bonding and hydrogen bonding interaction in net complexes. Sir, please.